Hi, my name is Mike Schwarz and I'm Managing Director of iTech Minerals. So today I wanted to give you a bit of an insight into the pipeline of graphite drill targets that we are generating at our Campoona Graphite project on the Eyre Peninsula. And also show you some of the clues and information that we use to identify where we believe some of these graphite resources may be hiding. So the most important geological clue when we're trying to work out a graphite drill target is basically mapping the geology on the ground. If we see it a number of places like we have at Lacroma or Lacroma North, that we've got outcropping graphite, that's a really good place to start. And then we can build on how extensive that graphite mineralisation might be. So then we go to something like the electromagnetics, and graphite being a good conductor, it often causes anomalies. If we have an extensive electromagnetic anomaly, suggests that graphite might extend for quite a way under the ground, and therefore we've got the potential for a sizable resource. Now, electromagnetics doesn't tell you everything. There's a lot of other things that can produce electromagnetic anomalies. So we have to put them all together like a jigsaw puzzle and work out which anomalies is going to show us where there's extensive graphite mineralisation beneath the surface. So let's start out by looking at Lacroma Central, because that's something we know quite well. The reason we targeted Lacroma first was primarily we knew that it stuck out of the ground. So it outcrops at surface, and there had been metallurgy done at Lacroma Central that told us we could make a high quality concentrate. So when you're drilling out a graphite resource, it's very important to know before you spend $2 or $3 million on drilling out that resource, that you've got a good chance of turning that into battery grade material. So right here on my screen, I have an electromagnetic contour map. So an anomaly is where we get these red zones. So we look at all of these different anomalies and we think, well, what are the different factors we need to look at to make it a good drill target? It looks really red down over this left-hand side, which is out to the west. But what we know is that there's an old river system out here that's been buried, and that contains a lot of salty groundwater. Now, salt water is conductive, so that's going to produce electromagnetic conductive anomalies as well. So we can map those out if we have a look at the topography, or what we call the digital terrain model. So if we see where those conductive anomalies are, you can see the blue is low and the red is high in the background in that image. So basically, this zone through here, which is just to the west of Lacroma, it's going to be really hard to find anything positive in that zone because it's masked by the salty groundwater. Now, there's a third thing that also causes conductive anomalies, and that is manganese. And we've got that here as well. So on the edge of this paleochannel system, there is another line of anomalies that run just inside here, which we know are all caused by manganese mineralisation. So you can see it's not very straightforward in picking out which of these are caused by graphite and which aren't. So we have to use all these other clues to give us a good understanding of which ones are good targets. So back in the mid-80s, Western Mining came and drilled a whole lot of holes over there. And what I've done is map out all the historical drill holes that have had graphite identified in them. So most of those haven't been analysed, they're just in the drill logs. So we have Lacroma, there's some old historic holes that have graphite there, and our drilling tells us, yes, we've got good graphite at Lacroma Central, but we look further to the north and we can see that there's quite a few drill holes with graphite in them here as well. And what we can see there, if we zoom in and enhance it, this is the prospect we're calling Lacroma North. So if it's graphite causing that anomaly, which we believe it is from the drill holes, then we know that a very similar geological situation exists to Lacroma Central. So it's very likely that metallurgy will produce a good concentrate as well. And that then tells us that's probably a pretty good target to go and drill for graphite. Now, I'm sure there's one other thing that you can see on the screen that's really sticking out, which is a real red, intensely high conductor over here. Now that is Balumbah. And we can check that, yes, as we checked from our logs before, there are 3 drill holes in a line that all have graphite in them. Now, if we have a look at the intensity of that one, we can see that anomaly comes up with a value of about 390. So that's quite a strong anomaly. If we go back to Lacroma Central, so that one comes out at about 120, 130. So we know at Lacroma Central we've got drill holes that have 90, 93 metres at nearly 7% graphite. So Balumbah being 390, we would then infer that there should be more graphite there that is causing that higher intensity anomalies. So there's a clue we can get to answering that question is if we jump over to the old drill logs, we can see where the drill hole is on that screen, and we find the right drill hole number, hole CP601. And what we can see from those drill logs is that in the top 20 or 30 metres, there are paleochannel sediments there with a bit of water in them. So at least part of that anomaly could be enhanced by salty groundwater. But importantly below that, there's a good 20 to 30 metres of nice graphitic schist that has been logged. Now, what about manganese? That can contribute to it as well. Well, luckily, Western Mining tested for manganese, and we can see that there's only, the maximum it comes up to is about 300 or 400 ppm or parts per million manganese. So that's nowhere near enough to cause an electromagnetic anomaly. So the three things, the high intensity anomaly, the graphite in drill holes, and the scale of it, because it runs for about 1.5 to 2 kilometres, all tell me that will become a good graphite drill target. So now that I've shown you a lot of the geological data that we use to generate our drill targets on the Campoona Graphite project on the Eyre Peninsula, you'll have a lot better understanding about the process we go through and how we prioritise which drill targets we're going to drill first. Now, there's a lot more to it than just doing this drill target generation in the office. We have to go and talk to landowners to get permission to drill on their properties. We have to do ground truthing and a whole lot of logistics to be organised before we get that drill rig turning out on the ground. So hopefully that gives you some insight into the drilling programs that we have coming up in 2024 and how iTech intends to add more resource tonnes to our currently growing inventory.